Okay, so today we're looking at linear equations again, and this time we're going to use the graphs to solve some problems. So the first thing we're going to look at is something called the point of intersection. A point of intersection is where things intersect, funnily enough, and we're looking at particularly two lines and where they meet. Now the point that two lines meet is special because at that particular point both equations are true. Okay, so I can solve the point where two equations are true at the same time. So for example, if I had the equations y equals negative 2x plus 3, okay, I would start by drawing that on a number plane. How am I going to do that? What's the quickest way of drawing this on a number plane? What do I need to know? What's the quickest way? We don't want to do a table of values that slow.
The crossover is 3.
We haven't got the second equation yet, so we've got a crossover yet. We're going to start with the y-intercept. Okay, my y-intercept is 3.
Yeah, that's what I was talking about. It crosses over the y.
It crosses the y-axis 3. What does this tell me? What's this number? This was my y-intercept. This is revision. What's this one? Gradient. Gradient. How can that help me draw it? What can I do to draw it? Yep. What does a gradient of minus 2 tell me to do? So starting here, go down 2 and across. There's no number on the bottom. What would I go across? 1. 1, because it's on 1. Well done, Sam. So I go down 2, across 1, and that's my other point. Alright, so now I'm ready to draw this line, which of course you're doing with a ruler. Tamadeo, you're using your ruler, aren't you? Yours doesn't look anywhere near as dodgy as mine. And I've drawn the line y equals 2x minus 3. Okay, everyone happy with that one? Now I'm going to give you another equation. This equation, we're going to do it in a different colour. We might do it in green. This equation is,
Y equals.
we're going to go super easy. Let's do y equals x.
Ooh, x.
What does that look like?
Yellow.
What's my y-intercept of this one?
They're the same, isn't it?
Yeah, you're right, they're the same. The x and y are the same. What are they? 0. So this graph here has a y-intercept of 0. Is everyone happy where they got that from?
Yeah.
Because there was nothing added on. What's my gradient?
X.
0.
There's no number here.
So it's a 1.
It's a 1. So how do I... It's an invisible 1. So I know that I have to go up 1, but how far do I go across?
0.
1. Yes, because this is invisible 1 on 1. That's invisible. Okay? So I'm going up 1, across 1, and now I can draw my line.
They intersect. What does that mean, Liz?
Y equals x.
They both
And this one was y equals minus 2x plus 3. Now you'll notice, that my graphs meet at a particular point. Can anyone see what point it is that they meet at? What's the coordinates of this point?
1.
This point here is the point 1, 1. That's correct. Now this is a very special point. It is called the point of intersection. It is where both graphs are true. Okay? So it's the point where both graphs are true. Okay? And so I know that there is only one point where both this equation and this equation are true at the same time. Okay? We sometimes call this simultaneous equations, because what does simultaneous mean?
Exact
time.
At the same time. Okay? So for them to be simultaneously true is only true when x equals 1 and when y equals 1. That's the only point they are simultaneously true. Can someone open the back
It's
door?
Rwan van Vliegberg.
It's 1.
He dropped the claws.
Bye, Ron.
This is for Reese. Yes, too.
Next door. Next door. We swapped classrooms, sorry.
Special.
Okay,
This is away.
let's look at another one. Shh. Quiet.
Yeah, you screw up all the time.
Yes. Nick.
Yeah.
Okay, so I've got this equation. So I've got y equals 4x minus 2 and y equals 3. Actually, let's make it x equals 3. Okay, first one. Shh. Charlie. Gerhard, please don't do that. Okay, this one, what's the quick way of drawing it? What's the first thing I notice?
The y-intercept is -2.
Well done. The y-intercept is at -2.
Hush.
Okay, what's my gradient and how do I use it? My gradient is 4. How do I use it?
No idea.
I go up 4 and across 1. So up 4, 1, 2, 3, 4, across 1. Charlie, focus. Okay, did you understand what I did?
Yeah.
Went up 4 across 1. Gave you my second point. I use a ruler and draw them up beautifully. That's y equals 4x minus 2. What does this one look like?
0.
Does anyone remember what the line x equals 3 looks like?
3 over 3.
So it goes straight up and down. So I go across to x equals 3. Here. Okay. So the line x equals 3, Olivia, you're writing this down. I go along to the line x equals 3 and it goes straight through x equals 3. Now I've come to a problem. My graph is so appallingly badly done,
Yeah.
I can't actually read the answer. Okay? Shh.
Unacceptable.
Quiet.
I'll top read this.
If you get to this point, you're a bit stuck, aren't you?
Yes.
You're going to have to start again with your graph. So what have I done wrong? That's the problem.
You need to make a bigger table.
I didn't make it big enough.
Yeah.
Also, there's something else that's wrong. One, it wasn't big enough. What else is wrong?
Didn't use a ruler.
My lines are wonky. And if I'm going to try and read where they cross off my graph, and I've gone all wonky, I'm not going to get the right answer. So what should I be really careful to do when I'm graphing these?
Rulers for days.
Use a ruler? What else would be really helpful if I was drawing on?
Wear glasses
Like
so you know
the
what you're drawing on.
Keep your hands steady.
What will be helpful? If you are on grid paper, okay? Now, shh, quiet. If you are on grid paper, it's going to be easier to see what's happening. So if I've gone up 4 across 1, shh, I can then count up another 4 across 1, up another 4 across 1. It's going to be much easier to make sure my graph stays accurate for the whole picture. Because I can't read the answer of that, it's just impossible. Okay? If I had drawn my graph properly, Bryce, then I'm going to find that the solution's all the way up here. It's off my board. Alright? I need to find out, how else could I find? So my graph's not helped. I've done a really bad graph. What could I do now? Does anyone think of what I could do? How could I
You've been hacked.
How could I find? I don't care about all the numbers in the table. There's only one number I care about. Which one is it?
3.
3. Why do I care about 3?
Because of pi.
That's what equals x.
Because I know that x-axis equals 3. So I could just put the 3 in here and work out where it is. And that means that I'm lucky that I don't have to redraw my graph. So in this one, Bryce, what does this give me?
12 minus 2, 10.
10.
So smart.
So if I had drawn my graph beautifully, I could have seen that it crossed at 10. So the point where they're simultaneously true, the only point where both this equation and this equation is true